Hello guys, IT Shiesty here. Welcome to the channel. Today we'll be diving deep into something super important in the world of networking, IT, cybersecurity, anything tech related. And that is the OSI model. And yes, I'll be making a series. Each video will be talking about each one of the 7 layers of the OSI model. And today, for the first part of the OSI model series, we'll be talking about the physical layer, the layer 1. So what exactly is the OSI model? Well, OSI stands for the Open Systems Interconnection, which is just a fancy way of saying it is a framework that helps computer systems talk to each other. Imagine you're sending a letter to a friend. The letter needs to go through several steps, like getting written, put into an envelope, getting mailed, sorted, and then delivered to the right house. The OSI model works kind of like that, but for data being sent over the network. The OSI model breaks this process into 7 layers. Think of these layers as steps that your data goes through from your computer to another device, like a server or your friend's computer. It is also important to remember that the OSI model is more of a flexible framework than a strict set of rules. In reality, not every system uses all 7 layers exactly outlined. Some layers might be combined or skipped depending on the technology or the system. The OSI model just helps us understand different processes, even if every device or network handles these steps differently. The OSI model is also commonly used in troubleshooting and also are used by MSP providers, network technicians, troubleshooters to find out what problem is happening between the data transfer from one device to another. And that helps us understand what we need to fix and what the problem is at hand. Now, one problem that you might be experiencing is that you don't know much about IT. Well, if you don't, then you should like and subscribe to my channel, because I'll be uploading more videos teaching you about cybersecurity, IT, and all that good stuff. Now, let's get started with the physical layer, layer 1. The physical layer of the OSI model, layer 1. The physical layer is the foundation of the OSI model. It is responsible for physical transmissions of data across a network. This layer defines the electrical, mechanical, functional, and procedural specifications for activating, maintaining, and deactivating the physical connections between devices. What is the physical layer? Fundamental communications. The physical layer ensures the reliable transfer of data bits between networked devices. Hardware specifications. It defines the physical characteristics of the network, such as cables, connectors, and signal transmission, electrical signaling. The layer encodes and decodes the digital data into electrical signals that can be transmitted over the physical medium. Transmission of binary data. The physical layer converts the computer's digital ones and zeros into electrical signals that can be transmitted over the physical network. Now that's digital signals. In regards to analog signals, for certain media such as telephone lines, the physical layer must also handle the transmission of analog signals. Signal encoding. Various encoding schemes like Manchester or NRZ are used to represent digital data as electrical signals. Physical devices and cabling. Number 1. Network interfaces. Network interface cards, also known as NICs, provide the physical connections between devices and the network. Number 2. Cable and connectors. Ethernet cables, fiber optic cables, and various connector types are all parts of the physical layer. So pretty much any cord that you connect to your computer, router, switch, hub, and they lie under the physical layer. Number 3. Repeaters and hubs. These devices regenerate and distribute electrical signals to extend the reach of the network. Wireless communication. These 3 wireless communications also come under the physical layer, and they are transmitted via radio waves. Now, Wi-Fi, such as the wireless local area networks, WLANs, are based on the IEEE 802.11 standards. And now Bluetooth, short-range wireless communication for personal area networks, PANs. Now cellular networks, wide area wireless communication using cellular towers and mobile devices. Analog versus digital signals. Analog signals, continuous electromagnetic waves that can take on any value within a range. Examples include telephone and radio signals. Digital signals. Discrete electrical pulses that represent the binary ones and zeros of digital data. These are used in modern digital networks. Signal conversion. The physical layer is responsible for converting between analog and digital signals as needed. Real-world examples. Some real-world examples may include Ethernet cables, which is a wired local area network or a LAN, technology based on the IEEE 802.3 standards using the twisted pair copper cables. Wi-Fi, or the wireless local area network technology based on the IEEE 802.11 standards using radio frequency RF signals. And another example is Bluetooth, the short-range wireless personal area network or PAN technology using low-power radio frequencies. Importance of the physical layer. The physical layer is the foundation upon which the entire OSI model is built, enabling the basic network connectivity. Issues at the physical layer can have far-reaching consequences, affecting the performance and reliability of the entire network. Ongoing relevance. As network technologies evolve, the physical layer remains a critical component, adapting to new hardware and transmission media. Now that sums up the video about the first layer of the OSI model, the physical layer. In the next video, I'll be talking about layer 2, which is the data link layer. So get ready for the next video. Thanks for watching, like and subscribe, because I'm Paul. IT Shiesty out.